Mr. Sutherland.
Good morning, Mr. Chairman, members of the board. My name is Andrew Sutherland, and I'm the Technical Program Manager of the MFLs program. The purpose of the presentation today is to provide you with a brief overview of the district's MFL program and the purpose of MFLs. As you know, according to Florida Statute 373-042, water management districts must set the limit at which further withdrawals would be significantly harmful to water resources or ecology of an area. It's important to understand that the condition of water resources can change due to drought, due to nutrient enrichment, structural alterations, etc., but that the MFLs are only supposed to deal with significant harm due to water withdrawal. We're not setting an MFL for ideal or optimal conditions, but rather as a backstop to significant harm. According to the Florida Water Resource Implementation Rule, water management districts must also consider other environmental values and beneficial uses when setting MFLs. Our goal is to set MFLs based on the most sensitive or constraining environmental criteria. We typically look at more than wetlands and soils, although if you've looked at some of our reports, these are often the most sensitive criteria. We also look at the effects of the recommended MFLs on things like recreation, navigation, filtration of nutrients, etc. Our goal is to ensure that the MFL we set protects these 10 values and beneficial uses. As an example of setting MFLs on the most sensitive or constraining environmental criteria, the DeLeon Springs minimum flow, which was recently adopted into rule, is based on the habitat requirements of the Florida manatee. Once we determined that manatee winter refuge habitat was the most sensitive criterion, we worked with the Florida Fish and Wildlife Commission to set a minimum flow that ensures no significant harm to the Florida manatee. But then next we looked at the other 10 environmental values mentioned on the previous slide to ensure that the recommended minimum flow protected those values as well. Typically, we set MFLs as elevations based on some sensitive environmental criterion or target elevation, for example, the depth necessary for fish passage or the elevation of a hardwood swamp. It's important to note that a system's water level relative to this target elevation varies naturally. It is sometimes above this target elevation and it is sometimes below this target elevation. MFLs are designed to ensure that the water level is above the target elevation for sufficient duration and frequency to protect the most sensitive environmental values. So again, the main point of this slide is that the hydrology of lakes and rivers varies naturally over time, and that we are setting MFLs to ensure that water withdrawal does not alter this natural variability too much. When we set MFLs, first we look at what is known as the baseline condition. This represents the current hydrology of a system and includes variability due to both climatic and man-made factors. That's the top line on this graph. The second line, the bottom, is what we call the MFL condition, which defines the amount of water necessary to sustain the environment and those types of beneficial uses I mentioned. When we compare these two conditions, these two conditions, the baseline and MFL, we determine if there's water available for withdrawal. This is the so-called sustainable yield or freeboard. Once we've determined an appropriate MFL or multiple MFLs in some cases to protect the most sensitive criteria in a system, the next step in the process is to assess status, both current and future status. First, we look at current status to determine if the MFL is being met today with current water use demands. Next, we look at future water use demands to determine if the MFL will continue to be met within the planning horizon. To determine if a prevention strategy or recovery strategy is needed, first we determine if the MFLs are currently being met. So this is the first question: are they being met under current water demands? If the answer is no to this question, then it is said to be in recovery and a strategy is needed to ensure compliance with the MFL. If the answer is yes, it's met under current demands, then the next question is whether it's being met at the planning horizon. Currently, we're using the 2035 water use demand for this planning horizon assessment. If the answer is yes to the second question, then no action is required. If the answer is no to this second question, then a prevention strategy is necessary to ensure that the MFL won't be violated within the planning horizon.
Can we back up one, Mr. Chairman?
Sure.
Doctor, one question. Are you extrapolating data
over a period of time? Are you capturing a point in time and averaging that? How are you getting to
Whether
2035 demand?
we
How
look
are you
at the
projecting that? Because population doesn't necessarily keep going up.
right, we look at
We got halfbacks, you know.
we look at groundwater model predictions, and we look at what the projected use is at various times in the future, and we compare that to what the use is today. So the first step is to look to see if it's currently met. If we say that it is, then we need to look at what the projections of future use are, again using the groundwater model, to then compare to that. If you remember back a few slides, this idea of sustainable yield or freeboard. So if we have that freeboard, then we compare that future water use, and it's a balance accounting basically. Is that future water use more than the freeboard we have less? If it is, then we need a prevention strategy.
Are you extrapolating and projecting freeboard, or are you using that?
No, the freeboard is set at the current condition, and then we subtract from that what the future use would be. And someone who's more in water supply could probably get into more detail about those projections. But
Okay, thank you. Thank you, Mr. Chairman.
and so if a prevention or recovery strategy is needed, the district engages stakeholders into a collaborative process which potentially includes providing tech support, engineering analyses, and cooperative funding. So to date, the district's MFL program, which began in 1990, has adopted 124 MFLs, which includes 101 lakes, 6 rivers, 7 wetlands, and 10 springs. We have also reevaluated 30 MFLs to date. The priority list for the current fiscal year 16-17 includes the following MFLs. MFLs for DeLeon Springs and Cowpen Lake became effective. They were adopted. They came before you in December of last year, and they became effective on February 1st of this year. We're currently working to finish 4 outstanding Florida Springs, Silver, Silver Glen, Alexander, and Gemini, to meet the July 1st, 2017 date set by Senate Bill 552. Also on our priority list for this calendar year are Lakes Brooklyn and Geneva in Clay County and Lake Sylvan in Seminole County. So next month we will be bringing the Silver Springs MFL to you for the notice of proposed rule, and in May we will be bringing our final 3 outstanding Florida Springs, Silver Glen, Alexander, and Gemini for their notice of proposed rule. Any questions?
Questions or comments? All right. Thanks, Andrew.